Welcome to the Explainer. Okay, today we are going to completely demystify complex math and data structures and turn them into a practical superpower for your real-world decision-making. We're looking at quantitative analysis. I mean, if you've ever wondered how the world's biggest companies solve their most complicated logistical nightmares, mapping global supply chains, optimizing thousands of employees' schedules, or routing cargo planes through literal hurricanes, well, you're in the right place. We're going to take raw data and turn it into gold. Let's get into it.
$150 million. Think about that for a second. That is exactly how much Taco Bell saved in the mid-1990s. And how they do it? They didn't invent some crazy new taco. They didn't slash wages. No, they just used forecasting and scheduling models. By applying quantitative analysis, they optimized exactly when and where they needed their resources. It's a real game changer.
Okay, let's dive into this. Here is our roadmap for today. Part 1, we'll look at the overview and power of quantitative analysis. Part 2, quantitative versus qualitative data. Part 3, the 7-step QA approach. Part 4, developing a quantitative analysis model. Part 5, data and testing solutions. And finally, Part 6, analyzing and implementing those results along with some key limitations.
Let's kick things off with Section 1, the power of quantitative analysis and objective decision-making.
So here's the thing. High-stakes corporate problems, they simply cannot be solved by a manager just going with their gut. Decisions based on intuition alone can be heavily biased or honestly completely inaccurate. We need objective evaluation. And the scale of this approach is absolutely staggering. It's not just Taco Bell. Between 1996 and 2000, NBC television increased their revenues by over $200 million simply by using quantitative analysis to develop better sales plans. Then in 2001, Continental Airlines saved over $40 million using these models to quickly recover from massive weather delays. That's real money. It's repeatable, it's testable, and it is incredibly lucrative.
Let's anchor this with a formal definition so we know exactly what we're dealing with. Quantitative analysis is essentially a scientific, systematic approach to decision-making. We take raw data, process, and manipulate it using mathematics, statistics, and optimization techniques and transform it into meaningful information. Basically, it's all about making better decisions.
Moving on to Section 2, quantitative versus qualitative data. Let's look at the distinguishing factors.
To be a true data detective, you really have to understand the difference between what can be measured and what cannot. So, the crucial point is this. Quantitative data is measurable. It's expressed and interpreted numerically. We are talking about investments, interest rates, inventory levels, and labor costs. Qualitative data, on the other hand, is non-measurable. It's really difficult or, frankly, impossible to express in numbers, and it's usually categorized by environmental factors like, the weather, new state legislation, or a sudden tech breakthrough.
But here's a secret that the absolute best business leaders know. While our explainer today is super focused on the math and the measurables, a truly great decision often requires both quantitative and qualitative considerations. You really have to blend the hard metrics with those non-measurable human and environmental factors if you want to see the whole board.
All right, Section 3, the 7-step QA approach. Let's look at the structured sequence.
And this brilliantly illustrates the exact step-by-step investigative roadmap used by the pros. We start right at the top by defining the problem, then developing a model, acquiring input data, developing a solution, testing that solution, analyzing the results, and finally implementing them. Notice those dotted arrows going backwards? That's because if you test a solution and it fails, or the data's wrong, you loop right back up to refine your model. It's a completely iterative scientific process. Step 1 is defining the problem. And honestly, this is the most critical and often the most difficult step. You have to focus on the root cause, not just the symptoms. A bad problem definition is just saying sales are low. That gives us nothing to work with. A much better definition is monthly sales decreased by 15% due to increased delivery time. Boom. Now that is clear, it's measurable, and it's specific. It gives our math a clear target to hit. Which brings us to Section 4. Developing a quantitative analysis model. This is step 2 of the approach. So, what is a model? A model is basically a simplified mathematical representation of a complex real-world situation. To build one, you really need to understand its anatomy. Models generally consist of variables and parameters. You have controllable variables, also known as decision variables, which are the choices you can actually make. Then you have uncontrollable variables, which are the random environmental factors you just can't manipulate. The output variable is your final computed result, And your parameters? Those are the known fixed values that stay constant throughout your analysis.
Let's ground these abstract concepts with a highly relatable example, like running a retail store. Your controllable variables are things like how many employees you schedule for a shift or the selling price of a product. Your uncontrollable variables? That's customer demand, or maybe a sudden snowstorm that completely ruins your foot traffic. Your output variable is what you ultimately care about, like your daily profit margins, or maximizing the utilization of your physical store capacity. And your parameters are the fixed realities, like your monthly rent or the tax rates. See how clearly that organizes a messy business? It's like putting together a giant puzzle.
Moving to Section 5, Data and Testing Solutions. We're going to acquire, solve, and test.
Now, what's really interesting about this next part is we have to address some vital issues and limitations in quantitative analysis. It starts with a massive warning sign built into Step 3, known as the GIGO principle. Garbage in, garbage out. It highlights one of the core limitations of the methodology. Math literally cannot fix bad data. If you feed your pristine model inaccurate, biased, or poorly collected input data, the process is only going to generate garbage information as a result. Poor data inevitably leads to poor decisions, plain and simple.
But if your data is solid, you move to step forward, developing a solution. The goal here is finding the absolute optimal outcome. Analysts use a variety of techniques for this. They might use algebraic mathematical equations, complete enumeration where they list out every single possibility, brute force trial and error, or complex step-by-step algorithms. For our retail store example, this means running the numbers to try different staffing levels, finding that exact sweet spot that minimizes cost while still perfectly meeting customer demand. But before you take any action, you hit Step 5, testing the solution. This is the ultimate reality check. You test both your input data and the model for accuracy. You might even collect brand new data just to test the model again. You really have to step back and ask human questions. Does this solution actually make sense? Are these results realistic? What happens if our uncontrollable inputs change suddenly? The results have to be totally logical before any business risks its money.
Now for Section 6, Analyzing and Implementing Results. This covers Steps 6 and 7.
This is where the mathematical model leaps off the spreadsheet and directly impacts real-world business strategy. In Step 6, analysts don't just hand over a number and walk away. They interpret the meaning of the solution. They look deeply at the organizational impact, like, will this require layoffs? Will it require new software? A really key part of this step is performing sensitivity analysis. This is another way we manage the limitations of predicting the real world. Sensitivity analysis determines how much the output changes if the input values fluctuate even slightly. It tells you exactly how sensitive and, frankly, how fragile your solution is to the unpredictable reality we live in.
Let's move to the end and see how this all builds together. You've defined the problem, modeled it, fed it pristine data, solved it, tested it, and analyzed the impacts. Now in Step 7, these objective, measurable, and repeatable solutions are finally put into action, potentially saving or making the company millions, just like we saw with NBC and Continental Airlines. So we'll leave you with this final thought. We've seen how transforming raw data into meaningful information removes bias and drives massive success. When you are facing your next major business hurdle, will you rely on pure, risky intuition? Or are you ready to step back, define the variables, and let raw data solve the problem? Thanks for joining us for this explainer, and we will see you next time.